I'm V. John Reddy, working as an assistant professor in the Department of Physics from Nalla Narasimha Reddy Engineering College. Today we are going to discuss about a small topic regarding the lasers. A laser is a device that emits the light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. The laser term stands for light amplification by stimulated emission of radiation. The stimulated emission was theoretically explained by Albert Einstein in the year of 1917. Later, based on Einstein's hypothesis, the first laser was constructed in the year of 1960, that is ruby laser by T. Myman. The basic principles in the lasers is absorption and emission. Okay. For an atomic system, the mechanism of the light emission. For an atomic system in thermal equilibrium with their surroundings, the emission of light is the result of absorption. The first absorption means here we are taking the one atom. The atom is consisting of different energy levels. Here I am taking the two energy levels E1 and E2. Energy levels E1 and E2. E1 is the lower energy state and E2 is the higher energy state. And the energy difference between these two energy states is E2 minus E1. Here for the absorption process, a photon of energy h nu which is equals to E2 minus E1 is incident on ground state atom. That ground state atom absorbs that energy and that is excited to higher energy state. That is, the atom is transition from E1 to E2. This process we call the absorption. The next one is the stimulated emission. Emission is divided into two types, that's the stimulated emission and spontaneous emission. And here the atom is excited. The excited state is unstable for the atoms. If the atom comes to ground state voluntarily after its lifetime, that is we are called the spontaneous emission. If the atom comes to ground state by the external force influences before its lifetime, that is we are called the stimulated emission. The first one is spontaneous emission. An atom initially present in the excited state makes the transition voluntary on its own without any aid of external stimulus or an agency to the ground state and emits a photon of energy h nu which is equals to E2 minus E1. This process we are called the spontaneous emission. In the spontaneous emission, the atom comes from higher energy to lower energy without any external influences. It comes to it completely freely. It comes from E2 to E1. This process of emission is we are called the spontaneous emission. In the spontaneous emission, we are getting one photon. That photon energy is equals to E2 minus E1. The next one is stimulated emission. In the stimulated emission is also the electron is coming from higher energy to lower energy state, but with the influence of external energies before its lifetime. Here we define as a photon having energy h nu, E2, that is E2 minus E1, E2 minus E1, which is present in the higher energy state. We instant one external energy that is h nu photon, which is equal to E2 minus E1. Due to this external photon, the atom comes to ground state before its lifetime. This process we are called by emptying the two photons. This process we are called the stimulated emission. Here we are instant external photon on E2 energy state. Okay. Due to this external photon, the atom is stimulated and it comes to ground state by emptying the two photons. But here the absorption process is not taken. Why? Because already the atom is present in the excited state. Here we are instanting the external energy. We are giving the extra energy to this atom. The atom is not excited to higher energy state. Another higher energy state, it comes to its original position by taking the that energy is not absorbed, and with the help of that energy, that it comes to ground state before its lifetime. And we know that the external excited state atom lifetime in the is energy levels is 10 to the power of minus 8 seconds, and the ground state atom lifetime is infinity. But excited state atom's lifetime is very small, that is 10 to the power of minus 8 seconds. In the stimulated process, we are getting the two photons. One is the emitted photon and another one is incident photon. These two are in coherent. Okay, the difference here, we are going to discuss about the differences between the stimulated emission and spontaneous emission, and few differences. As in the spontaneous emission, it is a polychromatic radiation, and stimulated emission is a monochromatic radiation. Polychromatic radiation means it contains a different wavelengths. Monochromatic means only one single wavelength light is emitted, and spontaneous emission is having the less intensity, and stimulated emission is having the high intensity. And the spontaneous emission is incoherent and stimulated emission is coherent. The spontaneous emission is having the less directionality and stimulated emission is having high directionality. And the concept of spontaneous emission is explained by the Niels Bohr, and the concept of stimulated emission is explained by the Einstein. Examples for this spontaneous emission is light from the ordinary electric bulbs and LEDs. Example for stimulated emission is light from the laser source. The next, the characteristics of laser light. The most important characteristics of laser beam are high monochromosity, high directionality, high degree of coherence, high intensity. The first one is high monochromosity. High monochromosity means the laser light is a monochromatic or a very pure in color. A laser beam is a single wavelength. High monochromosity means it is having only one single wavelength, and its spreading is also very less, that is the spreading of the light is also very less. And the directionality, the laser light emits only in one direction. The laser light emits only in one direction. Suppose if you take the ordinary bulb tube light, that is emits in all the directions, but laser is not emitted light like that. That is emitted light only in one particular direction, and that's why it is having the high directionality. And when it is traveled through the medium, the spreading of the light is also very less. Okay, the spreading of the light is also very less. That is where directionality is calculated in terms of divergency. The next one is coherence. We know that the coherence is two sources of light are said to be coherent if they have zero or constant phase difference between them. Then that is we call the coherence. Laser beam is both spatially and temporally coherent. The laser beam is both the spatial and temporal coherence. And another one is brightness. Brightness or high intensity. The laser beam is highly intense as compared to conventional light, because more light is concentrated in a small region. Why this one is having? Due to the high directionality, the complete intensity is located in a particular point. That's why it is having a high intensity. Okay.